5.2. I have to write this recurring decimal as fraction, and I have to use my knowledge of series to do that. So you need to remember that this 0.72, I can put a bar over there just to show that it's a 7 and the 2 that are repeating. I can write this as 0.72 plus 0.00 for these two, 72, and then I add another 72 at the end, so it's 0.000072, and then it continues in that manner. Okay, so this is a geometric series, so I take note what is my first term. My first term is 0.72, and then what is r? R is the preceding, the term that comes later divided by the one that comes before it. So I can do that on my calculator. 0.0072 divided by 0.72, and I get 1/100. Okay, so now that I know what A is, I know what R is, it is always good to test. Well, I know that this sum exists, obviously, because it's equal to this one, it exists, but it's always good. Get in the habit of testing that the sum exists. So here is my test. The absolute value of R, this is the absolute value of 1/100, which is just 1/100. 1/100 is less than 1, therefore the sum to infinity exists. Okay, so this sum goes to infinity, and I've written it in short over there. So if this sum to infinity exists, I just need to work it out. So the sum to infinity, this is the formula like we did in the previous one. A sub 1, this is 0.72, and then 1 minus R, which is 1/100. So again, I just do this on my calculator and then get a value, and my value must be a fraction because the question said write it as a fraction. So what do I have? 0.72, let's see, this is 0.72. Then I have 1 minus this fraction. Okay, I have 8/11. So I have 8/11. And we can always test 8 divided by 11 as a fraction. 0 point that. Okay, here you can see it has a 3 because it's rounded off, because the calculator cannot display an infinite number of decimals, so it rounds off over there. But if it was a calculator that didn't round off, you would see it continues 27, 27, and so on till we never stop.